Hello everyone. In this we will see next problem, which is island perimeter. Uh, Finding out the island perimeter. So you are given a row into column grid representing a map where grid ij is equal to 1 represents the land, and grid of equal to 0 represent the water. For example, all these are water. This blue color is water, and the inside this is which will represent 1, so it is land. And grid cells are connected horizontally, vertically, not diagonally. So they are connected vertically and horizontally. We should not think they are connected if they are connected like horizontally. For example, if this is a land and this is land, these are not two are not connected through diagonally. Like, we should not treat them as like one land. We should treat this is one land and this is one land. And the island doesn't have lakes, meaning the water inside isn't connected to water around the island. One cell is a square with side length 1. So here, like, this is will not be having like, island doesn't have lakes, and meaning like water inside isn't connected to water outside the land. So like, uh, it doesn't have lakes. And also, like, water inside, if for example, if we for example here, this the one let me just annotate it. For example here, if these these boxes are land and then this is water, like, he is saying this the island doesn't have lakes like this. And also the grid is rectangular. The width and height doesn't exceed 100 meters. Determine the perimeter of the land. So each square is side length equal to 1, and the height doesn't exceed 100 per 100 meter. And determine the perimeter of the island. We should determine the perimeter of the island. So let's see how we can solve this problem. So here, let's see how it is given. So here we have we will be given input this way. So here 0 represent the water and 1 represent the land. So here 0 1 0 0, that is what here we have. 0 1 0 0 and 1 1 1 0, 1 1 1 0 and 0 1 0 1 0 0. So 0 1 0 0 1 1 0 0, so 1 1 0 0. So we will be giving grid this way as a input, like two-dimensional array as input. And here our output is 16, because if you look at this highlighted yellow colored one, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So we have perimeter of 16. We should not consider these as a perimeter because they are connected inside. So we will not be will not treat them as a perimeter. So and let's go through our solution and see how we can solve this problem. So we have we have three solutions here. So the method 1, method 2 and method 3. I'll going to discuss method 1 and method 3. So method 2 is very similar to method 1. So if I so you can look into it by yourself. So coming to the solution, so I have taken this input example here in this our image. Let me. So initially we will be given input this way. This is the grid having the these values. So we will initially we will get that grid, and we will be counting the rows, number of rows and columns. So number of rows will be 4 and columns will be 4 here. And then we create a scene set to maintain, like, to maintain about the information about the cells which we already visited. So here mainly we are using here DFS. So This scene will be useful because otherwise it will go into infinite. For example, here we will be starting, and using DFS we come here and we go here and we stop here, and we will be coming again right side here. Let's assume this box also contains land, this cell also contains land. Then we'll be coming here, and then coming we'll come back here, and we'll be coming back here, and comes here, it comes here. And why there is nothing, so it will go back this way, and again it will go back. And again, if we doesn't had seen, then uh, it thinks we haven't, it goes this way again. But by scene set we are maintaining, like we are when we visit each cell, we'll maintain its like index as index in our scene. So let's go through the solution. While going the solution, you can get to know. So this is our grid, and also I have written our indexes, like how we in logic we treat each box. I have written here. So this is 0 0 0 1 1 0 etc. So initially we start from the first cell. So we in externally we run one for loop for rows, and internally we iterate through the columns. So initially for first box we check whether the grid is land or not. So it is not land, it is zero, value is zero, so it will not go inside this if condition. And then in next iteration we will be going here, will be going here, and at that time it will go inside if condition, and we'll be calling DFS, and we'll pass grid ij is 0 1, and row column which is 4 4, and scene is initially the empty. And in DFS we get those values, and we check whether it is if if it satisfies this condition. If it satisfies this condition, we'll be directly returning one. The reason why we are returning one here is, for example, if I is less than 0, so I is less than 0 when I will be less than 0. So I will be less than 0 when so I here I is 0, I is 1, I is 2, I is 3. So all at all these places I will be negative. So when I is negative, we will be having, we consider it as a edge, because if this will be a like edge, and we should consider it as a perimeter. And here when j is less than 0, when j is less than 0, j will be less than 0 when we will be here. And also, by the way, like around this square box we have to treat them as a water, we have to treat it as also water. So that is the reason, like we are thinking it as a edge. So here, like when j is less than 0, j is less than 0 for all these cells, and I is less than 0 for all these cells. And and also I is greater than or equal to rho. So I is greater than or equal to rho when for all these the below boxes, like when value comes here. And j is greater than or equal to rho when j value comes here. So for that all those things we should be going backwards. Looks like iteration will end there. And also if the grid value is 1, even if grid value is 1, like for example, while we are doing the DFS, for example, from this DFS we came here, and again it will check backwards. So again we should not go backwards. Like if we go backwards it will become like infinite. So that is the reason we will be checking those, that as well. So when I is less than 0, j is less than 0, or I is greater than row equal to row, or j is greater than or equal to column, and grid value is 1, we'll be considering we'll be just returning 1. So initially we started here here, like you can also see this tree as well. So initial DFS has started with 0 and 1. So I'm not in here in this tree, I'm not including the other values, I'm only including the ij values. So ij we got 0 1. So 0 1 0 1 is this, as you can see this as well. 0 1 is this cell. So once we come to this cell, we'll be checking whether this ij is present in scene. Initially it's not present, so we will go inside else if condition, and we will be adding 0 1. And then the next DFS iterate recursion starts. So the next recursion is it will go from here, it will go to 0 0. So in this DFS it will go to like where it will go. So here I is 0 and j is 1. Here also I is 0 and j is 0. So I j minus 1. So I and j minus 1. So for using this, it will go to this cell, and here iteratively we get 0 0. And here the condition like here this condition becomes true. Here we have or not and. So any case becomes true, then we will be going inside if. So this case becomes true here, because the value at this cell is 0, so we'll be going inside and it will return 1, and we'll be adding that 1 to perimeter. That 1 is this edge. And then again it will go from here, it will check 0 2. 0 2, which is I j plus 1. This will go this DFS will go here. And again this is also 0. Like here also we have value 0, so it will also return back 1. So or like it will be added to perimeter again, and that includes this edge. And again it will go to here, which is 1 1 comma 1, and 1 comma 1 is not 0, and also any of these conditions will not become true. So we'll be going again else if condition. So this is what we are doing here. So 0 0 we have went here, 0 0 0 2, and also minus 1 1 also, like I was saying, minus 1 1 also will return 1, because I becomes less than 0. So those are all things will return 1. So 1 plus 1, which is 3, I am including here in diagram. And we have we it will go to 1 1 1, which is from here it will go to 1 1. From here again it will check the left side, again left side also 1 1. So again it will check left side is 0 0. So it will return 1, and above is 0, again it will return 1. Below is 0, again it will return 1. And 1 plus 1 plus 1, which is 3. So we get 3 here. uh, those edges are like this: 1 edge, 2 edge, 3 edge. So 3 edges of this cell will return back. And it has covered left. It will see above 1 it will check like 0 1. It will we for I and j we get 0 1, and it will check these conditions becomes uh, like all conditions becomes false, so it will go here. And it will check this condition becomes false here, because ij already in scene, because already we have covered it. So it will not go there, and it will go right side. And it will this is one this cell is again land, and from this cell again it will iteratively do DFS to above, like right side and below. All are water, so it will all will return 1 1. So again this cell contains 3 like perimeter of 3, which is 3 edges. And again after covering this it will go to the below cell. Again this is a land, and this land again will check left side, which is water, right side water. So those two will return 1 1. And it will go down. Again it will check the left side again, and this will check again left side. Left side is water, above is water, down is water. So it will get the value of 3, which is the number of perimeter of this cell. And it will come back, this cell checked left side, it will now check right side. Right side is water, so we'll get value 1. And again it will check down. So now here down again I becomes greater than row. So again we'll get greater than row, and will get 1 again. So we will get 1 again here. And then we have covered left, right, down, and it will check for above 1. Above 1 is already we have covered, so it will go inside this else condition. And we have it will not go inside this. It will not go inside this if as well as inside else if as well, because ij already in scene. So in each cell we'll be adding like that ij to scene. So we'll be going back again because we have covered all the cells surrounding this cell. And here as well we covered left, right, down, and again above is already covered, so it will going back. And we have already covered here left, right, and down, and above one is already covered, so it will go back. And in each iteration, like while going back, it will add the number of edges which are connected to water to this perimeter. So if you see this tree, it will be very easy. So initially we get 0 1 here. From 0 1 we have looked at back, left, right, above. So 0 0 0 2, which is right, and above is minus 1 1. All has written 1 1, so it will be written, we got 3 here. And we came here to 1 1, which is this cell. And from here to we went to left side, which is 1 0. And from 1 0 to we gone to all these cells, which is 1 minus 1 0 0, and 2 2 0 2 0, which is below 1. And 1 1 1 1 is already covered, so all this will return 1, except this will not return. These threes will return 1 1, but this will not return 1, because these three recursion go inside this if condition, but this one thing will not go inside this if as well as this if, because here it will not go here, because the value at 1 1 is 1. This condition becomes false. And this will not go inside this if else if, because the ij is already in scene. So we get here 3 again. From 1 1 to, if we will be going here 2 1. From 2 1 to we'll be going to 2 0 2 0 2 2, and 1 1 1. All will return back, because already we cover this is already we covered. These two are all we have water. At these two places we have water. And we go to 3 1, which is this cell. And from 3 1 to we go to 3 2 3 1 3 2 3 1 3 2, and 2 1 2 1 is already we covered, and 3 2 is which is water. So we will go to 3 0, which we have like cell. So from 3 0 we go to 2 0 3 0 4 0 3 minus 1. So all is water except this which is 3 1. Except 3 1, everything is water. So 3 1 is this is 3 1 actually. 3 1 is already covered, so all these 3 will return 1 1, so we get 3 here. And from here like we have covered all. So from 3 0 2 we will come back to 3 1. From 3 1 we have already covered everything, like we have covered the here 3 and this one. So from 3 1 it will come back to 2 1. 2 1 also we have covered everything. So 3 here we have covered, and 1 is we covered here, so we'll come back to 1 1. From 1 1 2 it will go to 1 2 again. 1 2 1 2 we have cell. And from 1 2 2 it will go above all 4 sides. Again here we have water or already covered, which this is already covered, and remaining 3 as water, so this will return 3. So from here we have already covered, so we will coming back to 0 1. And from here we will be going we already have covered, so we'll be returning back. So total adjust we got, this will be returning 3, this will be returning 3, which is 6, and this will return 2 6 7 8, and this will return 2 9 10, this will be return 3 13, this will return 3. So total 16 we will get 16 perimeter as 16. That's how will be this iteration will work. So it if you gone through if you go through this way, it will be very easy to understand. So you can go through this way, it will be very easy for you to understand. And this is how the first method will work, and even the second method work in a similar way. So just instead of here in first method, I have used we are adding in scene we are adding I comma j, which is 0 comma 0 0. Like here we are adding 0 0 1 0, everything. Like here I have not included everything, but we'll be adding like everything while we are visiting. So instead of that 0 0, instead of adding as a tuple, here in method 2 we are adding as a string. So for example, let me just annotate it again. So here instead of 0 how we are adding is 0 1 underscore. Like this is as a string we are adding. So that's how we are keeping track of like already visited cells. So initially I was doing one wrong here. So I was just instead of like putting underscore, I was just like uh, converting it to string, like adding this and converting it to string and adding this individual character, and I was storing. But I came to know like this solution was getting wrong, because for think if we have it 2 1 3, in this case like 2 1 3 and 21 3, in both cases if we add up, then we get same string 213 213. So that's how for those conditions it was this condition this uh, program was failing. So that is the reason I have added underscore. So after underscore this program is working, because we'll be separating like first index with second index. And this is how the second solution will work. So this is very similar to the first solution. So you can go through it by yourself. And let's see the third solution, which is very efficient than the first two solutions. So this is like very efficient solution. So I will also take the one more image. So in this solution what we are doing is we are uh, in this solution what we are doing initially, like the above solution, we have calculated here row, column and perimeter. We have assigned we have taken these parameters. And also here here we don't need this set as scene. Actually I am not sure why I haven't defined, but here we don't need this scene as well. So here we'll be iterating through each cells, like above method, like above solution. And in each iteration, like what we are doing is, if we are checking whether if it is like land or water. So if we are land, if it is land, then we are going inside. So the main idea here in this solution is for each land we are counting perimeter 4. Like because each cell will have four edges. So we are counting all those four edges. Like we are taking here this is okay. Here we are counting it as a 1, but later we'll be doing multiplying with 4. So we'll be counting it as for each cell which is land, we are counting it as a 4. And along with that we are also checking one more condition, which is whether it has any neighbor lands. So for example, this doesn't have, this has only one neighbor land. So that this is also we are counting, keeping track of that value. For example, here we have perimeter 4, p is equal to 4, p is perimeter and n is neighbor. For all cells which is land, we will be having p is equal to 4 obviously. And for this we have only n equal to 1, because only one land is connected. For this also n equal to 1, for this n equal to 1, for this n equal to 4 because it is connected, all four sides are connected to land, and this cell are connected to two sides, this cell connected to this, and this cell connected to left side and above cell. So that is the reason n is equal to 2, and this cell is connected to the right side cell which is n equal to 1. So here we have 7 fours, so 7 into 4, and 4 ones which is like 1 2 3 4, 4 ones, and plus 2 twos which is 1 2, and 4 fours which is the middle one, 4 only ones. So we are what we'll be doing is we'll be subtracting these neighbors from all, because if any cell is connected to this cell, then it lost this one side, like we should not consider that as a perimeter because it has connected to the other land. So again this cell is connected to this cell, so it lost one cell. So similar way, like this cell is connected to this cell, this cell is connected to this cell, which means this cell lost one side and this cell lost one side. So that is the reason here n equal to 1 and here n equal to 1 added, and n equal to 1 from here, n equal to 1 from here, and 1 from here. So that is the reason n equal to 4 for this cell. So that's how like we are be subtracting, we got 12 cell or 12 neighbors we have, and 12 sides we lost from total 28 sides. So that is the reason we get 16. So that's how we get 16. So that's how this program will work. So like we iterate through the each cell, and here from here we check this is land, so we'll go inside if condition, and we do perimeter plus 1, and we check whether I is less than row minus 1, and I is and grid, the right side is land or water. We'll be checking whether the right side is land, and also we'll be checking I is less than row minus 1 because I should not go, we'll be checking here only two sides, one is right side and down. So for example for this cell we should not check for right side because we don't have any right cell. That is the reason here we are checking j is less than column minus 1, and for this cell we should not check down because we don't have for this cell, like we should not check right side as well as down as well. So here right side we are will be avoided by this condition, and downside will be avoided by this condition I less than row minus 1. So in from here perimeter equal to 1 1, and we'll be checking I will be checking for this cell, we'll be checking I which is this neighbor, whether initially we are checking the down one, so we are checking I is less than row minus 1, yes, and also this is true, like grid is value is 1, yes, so it will go inside this if condition, and neighbor it will add to neighbor, and again it will go to this right side, so right side is 0, so it will not go inside this if condition, and again for this cell this is 0, so this will this condition will becomes fail here itself, this, so again we come here and this becomes true, so this will check right side, initially check it will check down, this condition becomes false because 0 we have 0, and it will go inside this if condition, and we don't neighbor minus we will add to neighbor 1, and again we go to here, and here also we check only right side and downside both become true, and we go to inside both if conditions, and again we will be checking for this cell, and same way similarly like we will be checking for each cell, and we'll be getting neighbor, and neighbor as a 6, we'll be getting neighbors as a 6, like for here we get 1 2 3 4 5 6, we get 6 neighbors, so that is and we'll be doing 2 into neighbor, and we'll be subtracting from the 28. The reason why we are doing 2 is like here we are counting only one, like here we are counting only right side and downside, not like left side and above. If we would have counted left side and above as well, then we would have got directly 12 here in neighbor. Currently we are getting 6 in neighbor, 6 value in neighbor, uh, the reason is like we are checking only right side and down side for each cell. So this is our second solution, and this is iterating through this each cell only once. So that is the reason time complexity is order of n, where n is the number of cells, total number of cells. And the space complexity is this is not a DFS, this is not using DFS, but the above methods are using DFS. And the space complexity is order of 1, because here we are using just constant space like row, column, perimeter, all these are constant space. And above two methods are time complexity is order of n, because again here also we are iterating through the each cell. Like for initially, if we are coming from uh, here we are just if we encounter one, then we'll not be again iterating through this loop, but here recursively we are going through each cell. So that is the reason, if we got here one, then from here we are iterating through all these cells. So in worst case, all the cells will be land. So in that case, it will travel through all the lands, all the cells in a this given input. So that is the reason the time complexity is order of n, where n is number of cells in a given input. And the space complexity is order of n here, because we are using scene for storing the already visited cells. So in worst case where all the cells are land, we'll be keeping track of all the cells in a scene. So that is the reason space complexity is order of n for this method. And this time complexity and space complexity are same for this method as well. And yeah, that's all for this video. And thank you for watching, and I'll share the solution and these images in the description of this video. And thank you for watching.